Okay, so now this is just sitting on top of the light, right? So same box, the top is shut. On number 12, so basically this gets really hot. So I want you to think, where would you expect areas of high and low pressure to be? Like high pressure up here, high pressure down here, high pressure in the middle, whatever. Okay, so high, low, high. So just jot down what you think is going to happen when I turn on this light, and really all we're using is to generate heat. Okay. All right, so let's go ahead and put the manometer together here. So we're going to put the tube on the input port. Okay, so what we're going to do is measure the pressure here. All right, so we put that on. You can see that's on now. All right, so we're going to take the end of the manometer and we're going to put it up at the top. Okay, the top hole. Get in there. There we go. So we're at the top hole. All right, so I want you to think. So I want you to watch what happens to the pressure as I turn the light on. So you can see right now. Let me zero this out. So this is going to just sort of calibrate it a little bit. Okay, it's not calibrating for some reason. All right, I guess we'll just leave it at that. So we're at 0.1 right now. So I'm going to turn this light on. Okay, I'm going to turn the light on here, like so. I can get that. Kind of hard to do with one hand. There we go. All right, so the light's on. They're really just mostly generating heat at the moment. And so let's watch what happens to that top. So you're already up to 0.2. So remember, it's just generating heat. I'm not doing anything here. Oh, we're up to 0.3. So you can see the pressure is increasing. That's really the story here. So that's number 13. The pressure is increasing at the top of the box. And then number 14, what is the delta P? Wait till it stops. We're like at 0.3. It looks like it's not really going to get any higher. So that appears to be the answer to number 14. All right. Now we're going to go to number 15, the delta P at the bottom hole. Okay, so number 15, delta T at the bottom hole. So we're going to take our manometer out. Oops. And let's put it in near the bottom here. I guess we'll put it all the way. Be careful not to. All right, let's see what we have. Let's go about a minus 0.1. Minus 0.1, that's the bottom hole. Okay, so that's number 15. So number 16, I want you to explain why that's happening. Okay, high pressure at the top, positive pressure, and then negative pressure at the bottom. Okay, so explain that. So what I'm going to do is I'm going to go to each hole and measure the delta P. All right, so you want to jot this down. Looks like we're almost minus 0.2. Okay, so we'll start at the top, right? So here's the top hole. Okay, top hole. Wow, look at that. 0.4 to 0.5. Okay, the next hole down is here. Oh, looks like we're about the same. Okay, that's number 2. This is the third hole down. Still about the same, 0.4. Here's the fourth hole down. We're at 0.3 there. Fifth hole down. 0.3. Sixth hole down. 0.2. Next one down, hole number 7. About 0.2. Hole number 8. 0.2. Hole number 9. 0.1. Hole number 10. 0.1. Hole number 11. 0. 12. So this is the fourth one up. 0. Next one down. About minus 0.1. Next one down. Here we go. About minus 0.1. And here's the bottom hole. So it looks like that's the most negative we get. Okay, so that's all the holes from top to bottom. All right, and so you want to illustrate that on your lab. Okay. So, and then just as number 17, describe the pattern, and number 17A, describe the pattern, and 17B, make sure you integrate the approximately where the neutral pressure plane is. So neutral pressure plane, which is, make sure you know what that is. Okay, so now number 18, right? So you just want to kind of go through this. So where's the most positive and most negative delta P? And then that's, again, meant to approximate what's happening with the stack effect when you have furnace, you know, and all in the air is the warm air is rising up, right? And so that's what happens when you have that in terms of the pressure pattern inside a building. So I want you to think about that, and then think about, you know, if we have positive pressure up here with respect to outside, right? So positive pressure inside with respect to outside. And then here we have negative pressure inside with respect to outside, right? So it's higher pressure here than inside the box. And here the pressure's higher inside the box compared to outside. So think about how pressure causes air to flow and what that means for airflow in or out of a building at the top and airflow in or out of a building at the bottom. So where's air being pushed in and where's air being pushed out? And then what does that mean for cold air coming in and warm air escaping? Okay. And describe that in terms of delta P. Okay. And then you also want to, for number 19, explain why the answer, you know, the air movement in and out of the building, how that relates to the importance of sealing the top and the bottom of the building, right? So is it important to seal up here and down here, or maybe just down here and not up here? So think about the importance of sealing the top and the bottom. And then also, like, toward the middle, is it sort of less important? Is it more important than sealing the top or the bottom? Okay. And so you just want to discuss that. So that's number 19. So discuss that in terms of delta P and airflow and what that says about the importance of air sealing different parts of the house, right? And so number 20, finally, if you have a standard 2-story house with a regular foundation, where would you focus your air sealing efforts and why? Okay. And so that actually concludes the lab. So hopefully that worked for you. And of course, happy to follow up if you have any questions.